This is an example of a calculator that was manufactured in the 1970s in the Soviet Union. You can see here on the label it says iskra, which in Russian means spark. The display is interesting because it uses glass tubes filled with neon. And in each tube, what you're looking at is a glowing cathode, which is just a piece of wire that's been molded into the shape of a number. And there are several different cathodes in each tube, with each cathode bent into the shape of a different number. So by controlling which cathode is attached to the negative supply voltage, it's possible to control which one is glowing. The anode is a thin metal screen in front of the cathode. These tubes needed about 90 volts to operate. At these low voltages, although the entire tube is filled with neon, only the gas near the cathode is ionized. If we wanted instead to make the whole tube glow, then a much higher voltage would be needed. Electrostatics experiments don't work very well in Singapore because of the high humidity. So I'm here at beautiful Northwest Missouri State University in the middle of a dry winter in order to do some experiments today, and they very graciously allowed me to use their physics lab. Now, sitting behind me on this table are 3 different instruments, and each of these machines is capable of generating a very high voltage, high enough in order to break down air and hopefully make some sparks. We've got 3 tools: the Tesla coil, the Wimshurst generator, and in the back we have the Van de Graaff generator with the 2 large electrodes. Now, you might have seen a Van de Graaff generator before with only a single electrode. The other electrode is just a ground electrode. We'll start with the Van de Graaff generator and see how it works. Let me go plug it in. I've got the Van de Graaff generator plugged in, and when I turn it on, what's going to happen is that a motor is going to start running, and we'll develop a potential difference between these 2 electrodes that grows with the amount of time that the motor's been turned on. So when I turn it on here, eventually that voltage will get high enough and we'll get a spark between the 2 electrodes as the air breaks down, and then the process will repeat. So if I pull the electrodes further apart, the sparks should occur a little bit less often because it takes more time to build up that voltage. So let's turn it on. So we're getting sparks, and as I pull it apart, we're getting fewer but longer sparks. I've got a neon tube here with electrodes on the 2 ends. I can also get discharge through the neon tube. So let's fire up the Tesla coil. Now, the Tesla coil, unlike the Van de Graaff generator and the Wimshurst generator, produces an AC electrical field. In other words, the electrode here isn't just negative or positive. It's negative, then it's positive, then it's negative, then it's positive, and back and forth like that. And the electric field strength is very large enough to ionize some gases, but it doesn't last too long. So it oscillates. When I plug it in, we're going to hear kind of a buzzing sound. And I've got some glass tubes here filled up with various gases. And if I hold the glass tubes near the Tesla coil, it'll ionize the gas inside the tube. So we'll start here with argon. That's kind of a purple glow. Neon glows very brightly, and it's very easy to ionize. Now, if we compare that, for example, to hydrogen, you'll see that I have to hold the tube a lot closer to the Tesla coil, and the glow is not very bright. That's because the electrons are held very tightly in hydrogen, and it's more difficult to ionize. There's helium, mercury vapor, and krypton. You notice that they're all different colors, and of course that's because they're different gases and the electrons are in different orbits. In this video, we've seen that glass tubes filled with gases at low pressures are easy to ionize, and that this is very useful for lighting and to make displays. In the next video, we'll look at the 2 electrode setup again and consider what happens when the air is totally removed from the tube in the case of a vacuum. Can you have a spark between 2 electrodes when you don't have any gas between them at all?